Okay, 2011, Step 1 paper, question 2. So the number big E is defined by big E equals the integral from 0 to 1, e to the x over 1 plus x dx. So show that from 0 to 1, the integral of x e to the x over 1 plus x dx equals to e minus 1 minus big E. Alright, so that's the first part of the question. So what can we see here? Okay, so we've got two integrals, and one of the integrals has an x attached to it. Okay, so if I put a 1 in front of the e to the x, could we spot anything? Alright, we know the denominator is 1 plus x. Okay, so if we added the two integrals up, what could we do? Okay, so in the numerator we would have 1 plus x times e to the x, because you can factorize the e to the x, can't you? And the 1 plus x would cancel with the 1 in the denominator. Okay, so let's do that. So we know that x e to the x over 1 plus x dx, what is that equal to? That equals to e to the x on itself, because the 1 plus x cancels out, right? Minus e to the x on itself over 1 plus x dx, right? Because that's the 1 plus x bit, that's the 1 bit, so you're left with the x bit, which is that bit. Yeah? Alright, so we've established that. So that equals to e to 1 minus e to 0, and we know that is big E. So the first part comes out nicely. So e minus 1 minus big E. Alright, so that's the first part. And the second part says, and evaluate, so this time we have an x squared in front instead of the x itself. Okay, so basically it's the same trick, to be honest. Alright, there's not much difference between the parts here. Alright, so again, so 0 to 1. Okay, well, we've got x squared, right? So let's just look at the bit behind first. Okay, we could see that here, that bit there, yeah, is very similar to the integral just now, right? Okay, so we could split it like we did just now. So it will be e to the x subtract e to the x on 1 plus x, right? Yeah, because we could write it as a difference of these two functions, dx, fine. Okay, so now let's multiply, let's expand the brackets, shall we? All right, so now what we've got is x e to the x subtract x e to the x over 1 plus x dx, yeah? So the last bit here, we know is e minus 1 minus big E, right? Because we did that last part. But for the first bit, okay, it's an A-level integral, which is by parts. So we could do, so let's say u equals to x and v prime equals to e to the x. So we have u prime equals to 1 and v equals to e to the x. Okay, so we could write this integral as so uv minus v du. Alright, and remember to put your limits. Subtract, okay, we know that's small e minus 1 minus big E, right? From the previous bit. Okay, so from here we get 1 e to the 1 minus, okay, so integral of ex is ex itself, right? So minus e to the 1, and then we put 0 in, so that's minus 0, plus I put 0 into the ex, that's e to the 0. All right, minus e minus 1 minus big E. Fine, so we now have to do the maths. So that cancels with that. Yeah, it's both e to the 1 and 0 just doesn't matter. And we know that becomes 1 minus e plus 1 plus big E, which gives 2 minus small e plus big E. All right, so that's the first two integrals that we're asked to evaluate. Fine, so we move on to the third integral. So the third integral is saying that we have to integrate from 0 to 1 e to the 1 minus x on 1 plus x over 1 plus x dx. Okay, so how can we deal with that? All right, so the most intuitive way of going for it is to make a substitution, right? Because we know that the exponent has changed. Okay, so we would want a substitution for the exponent, such that we could try to make it into e to the u, and we could try to make it into our previous integrals. Okay, so let's do a substitution. So u equals 1 minus x on 1 plus x. So du would equal to what? All right, so u equals to 1 minus x, 1 plus x to the minus 1. So du would be equal to 1 minus x minus 1, 1 plus x to the minus 2, plus, well, actually, minus 1 times 1 plus x to the minus 1. Fine, okay, so dx. So that equals to, so if I write it in a common denominator, all right, so that's 1 minus x times minus 1, which is x minus 1, and minus 1 minus x, yeah? Because I've got 1 plus x left, but I'm multiplying by minus 1 here, all right? So that equals to minus 2 on 1 plus x squared dx. Fine, so what does that give us? So that would give us dx equals to minus 1 plus x squared on 2 du. Fine, so let's do our integral, shall we? So we have to transform our limits first. All right, so if I sub in 0, x is 0, then my integral is 1, my limit is 1, sorry. And when I sub in 1, then my limits would be 0, right? So kind of the limits has swapped. Okay, so we make our substitution e to the u over 1 plus x. Dx is minus 1 plus x squared over 2 dx. Yep, no, du, sorry. We're just making a substitution here. Okay, so we could see that the 1 plus x actually cancels out, right? We could see the 1 plus x does cancel out from top and bottom. All right, so that equals to, and the minus could swap the limits around, right? So we could do 2 steps in one. So we know that that's e to the u multiplied by 1 plus x over 2 du. Fine, so now we have an integral, but we still have an x involved there. Okay, so we might have to think about this a bit, all right? So we know that u, so the substitution we made was that, okay? So now I've got 1 plus x over 2, which is concerning, right? Because what I would much prefer is e to u over u plus 1, right? That's what we want, okay? That's what we want. So if we want u plus 1, why don't we check what u plus 1 is, right? Okay, so if we say u plus 1, that would be 1 minus x plus 1 plus x over 1 plus x. Yeah, we're happy with that. Equals, so 1 plus 1 is 2, which is 2 over 1 plus x. All right, so that's 2 over 1 plus x. So what's going on here? So in the integral, I have 1 plus x over 2. Okay, so that's essentially the reciprocal of it, right? So what I want is 1 over u plus 1, actually. 1 over u plus 1 equals to 1 plus x on 2, which is exactly what I could substitute into the integral. Okay, so if I do that, then my integral becomes the integral from 1 to 0. Let's go back here. So our integral is there. So my integral would be from 1 to 0, or no, from 0 to 1 of e to the u over u plus 1. Yeah? du, which is exactly e itself. All right? Okay, so we move on to the last bit of the integral, which is essentially asking us to integrate from 1 to root 2 e to the x squared over x plus 1, if I remember correctly. Okay, so what is this integral doing? Well, we know that, again, we could use a substitution, right? Because we know that we have to try to force the exponent to what we want, kind of. All right. So what substitution could we make? We can make u equals x squared, right? If u equals to x squared, then we know then we know that du equals to 2x dx, right? Okay, so the integral actually is x itself on below, sorry. All right, so that equals to, so u equals to x squared, that's the substitution that we want to make, and du equals to 2x dx, as we just discussed. Fine, so let's transform our limits. So that equals, the integral equals to what? So our integral now equals to the integral of 2 and 1, because we have to square it, right? E to the u over root u. Yeah, okay, well, don't be put off by the root u, okay, because after we substitute the du, then we will find out that it's, you know, a very comfortable integral, okay? So that equals from 1 to 2. Well, what is x? X is root u as well, right? So we know that that's e to the u over 2u, right? Because x is root u, and root u times root u is u itself. Okay, so now we've got that. Now what's going on? So firstly, we want u plus 1. Yeah, and the limits aren't quite right here, are they? They're 1 to 2, but what I want is from 0 to 1. Okay, so I have to substitute such that the limits become 0 and 1. So what could I substitute here? Okay, so let's say I use s here. So I want s to be 0. So what I want is u minus 1, right? Because if I sub in 2, so 2 minus 1 gives me s equals to 1, and if I sub in 1, 1 minus 1 gives me s is 0, which are the limits that I want. Okay, so if we make that substitution, then ds equals to du, there's no doubt in that, I think. So I now further equals to, from 0 to 1, e to the s plus 1, because u equals s plus 1, right? Over 2 times s plus 1 ds. Yep, okay, so now we actually have got, essentially, the integral that we want, okay? Because we could easily take out the constant, e over 2, and you could see that the last bit is essentially big E, right? Okay, so that integral equals to e on 2 times big E. All right, good. So that's all the integrals that we have here. Okay, so you know it's a bit of intuition when you try to substitute and try to force to change the exponent into something that we want instead of that complicated expression up there, and following the flow of the question. Yeah. So after you substitute, you just do whatever you like, it's appropriate, and you get to the answer. All right. Good. So that's the question.